Students, non-destructive inspection is the industrial laboratory process by which part or materials or entire system are examined without impairing their future usefulness. You want to satisfy yourself that in future this equipment would not fail and would do its job according to its built. So for NDI we do certain kind of tests. These methods, NDI methods, are as follows. We do the dye penetrant testing, that is the magnetic particle testing, ultrasonic testing, eddy current testing. Today we are going to study about the NDI method, that is radiography testing. Now, what is radiography? Students, you have ever examined that you have fall from a certain place and you feel that you are having a pain on your bones, in your arm or in your chest or anywhere in the body. You go to the doctor and doctor says that maybe you have a fracture in your chest, or maybe you are having a fracture on your arm. What you do? Doctor suggests you to go for a radiographic X-ray, that is X-ray. So in X-ray, after examining that X-ray, doctor suggests you that you are having a fracture, or you are having a serious kind of problems in your bones. So you do certain kind of things. Same things happens in the aircraft maintenance. If you are relying on different parts of aircraft and you want to examine that part and you want to ensure the proper working of that equipment, you do the radiographic testing or NDI inspection. Now, radiographic testing or industrial radiography's NDT method of inspecting materials for hidden flaws by using the ability of short wavelength electromagnetic radiation. These electromagnetic radiation is high energy photons. To penetrate various materials, radiographic testing method is nothing but to take the shadow pictures of an object onto the film by the passage of X-rays or gamma rays. Here we are having a calculator, and when we do a radiographic test of this calculator, we would have a picture like this. Here in this picture you are having everything. You can see that the PCB under that calculator. You can see the mics, you can see the display of this, and what is the inner picture of this calculator, you can see it. So this is all about the radiography. This is another example. In this example you can have a normal image of a torch, and you can have a radiographic image of a torch. Now in the radiographic image of a torch, you can examine the inner portion of the torch as well. Here you can find that whether the structure of this torch is totally serviceable, or there are some kind of cracks in this torch. Same can be opted on the aircraft maintenance. Students, when we use the radiographic apparatus or radiographic machines, these machines are divided into two portions. One is of X-ray productions, and the second is of gamma rays. In the X-rays production, we use a radiographic generator or X-ray machine which produce these X-rays, and when these X-rays pass through from this specimen, means to say the object which is to be examined. And here in this example we are having a crack, we are having a pore, we are having a channel, we are having a hole. All these have been filmed on an X-ray film, which is situated behind that X-ray, behind an object. So this is all about total process of radiographic testing. Now we use, as I have explained earlier, that we are using X-rays and the gamma rays in the radiography. There should be some kind of difference in the X-rays and the gamma rays. The difference in X-rays and the gamma rays are as follows. X-rays are having a larger wavelength as compared to the gamma rays, which are having shorter wavelength. Now X-rays are having the lesser penetration power as compared to the gamma rays. These are the high penetration power. So gamma rays can penetrate in the very, very thick metal sheet used for the components having thickness up to 62 mm. As you know that these X-rays are having the less penetration power, so these can penetrate up to the 62 mm thick sheet. But as compared to the X-rays, the gamma rays can penetrate into the more thick sheets, more thick components. So for thick components we would prefer to use gamma rays. Now in X-rays only one component can be examined at a time, which is in the focus. But in the gamma rays, by using the gamma rays as a source, we can examine many components at a time. At the same time, X-rays equipment is very large, it's a bulky equipment as compared to the gamma rays, which have the equipment which uses the gamma rays is smaller as compared to the X-ray equipment. The X-rays are more intense and faster, but the gamma rays have the less intensity and slow rate. The application for radiography. Now, where we use the radiography in our day-to-day usage, the radiography can be used for detection of internal defects, for detection of porosity and casting, lack of fusion in the welding or cracks, to find different kind of cracks, for measurement of geometry variation and thickness of components. You know well that equipments made of metals can expand, these can expand in the high temperatures. So we can measure the geometry of different kind of equipment if there is any variation in their geometry. So that can be find out through radiology. Now we should examine that what are the advantages and what are the disadvantages of radiography. And first of all, we are going to discuss something about the advantages which are related to the radiography. Students, this technique is not limited by material type or density. You can use radiography on every material, on every type or every kind of density. Secondly, the radiography can be used for inspection on assembled components. You need not to remove the component from a particular area. Thirdly, minimum surface preparation required. You need not to prepare a biggest surface area, or you need not to prepare yourself for a huge kind of job. This is not so big. You need to prepare a minimum surface for inspection. Now, sensitive to changes in thickness, corrosion, void, crack, and material density changes. This is not so. This is very sensitive to changes. That can find out the thickness. That can find out the corrosion is there. If there are cracks, if there are material density changes, if material is changing its density, then you can find out by using the radiographic techniques. Now this technique, the radiographic technique, can be applicable for defects which are related to the surface, or which the defects related to the subsurfaces. Both kind of surfaces are applicable for using the radiography. And this radiography provides a permanent record of the inspection. Means to say that record which is produced by using the radiographic technique would be a permanent kind of record for you. Now, after discussing the advantages of radiography, now we are going to discuss the disadvantages of radiography. Students, radiography can be very dangerous for your health if you are being exposed for many hours, for many times. Many safety precautions for the use of high intensity radiations are required. As you know that many hours of technicians training prior to use are required, because you need to train your technician who is implementing these tasks for safety aspects, for usage of a particular kind of equipment which is very sensitive and which is very delicate. Access to both sides of sample required. Means to say upper and the lower sides of access is required for the radiographic techniques. Orientation of equipment and flaw can be critical. You can have an image after doing the radiography, but the analysis of that image is very critical. A man of great experience need to examine that specimen for finding out any kind of flaw in that specimen. That can be a disadvantage of radiography. Determining flaw depth is impossible without additional angular exposure. So this is another disadvantage of radiography, that it cannot find out the actual depth of the flaw which you have found during the inspection. So this is a disadvantage related to the radiography. Now, expensive initial equipment cost. This is very expensive kind of equipment which is related to the radiographic techniques of inspection. Not everyone is having so much economy or the huge money to buy radiographic equipment at its labs or its maintenance